Okay, so here we are starting our video on the anterior hand. So this is an anterior view of the hand. This over here is the lateral side, the thumb side, the radial side. This is the medial side, the pinky side, the ulnar side, okay? And this is an anterior view. So in this video, we're gonna go over the bony landmarks, the carpal bones, the bones of the hand, the individual joints of the hand, what they're called, how they move, and then we're going to talk about all the intrinsic muscles of the hand. So when we say intrinsic muscles of the hand, we're talking about muscles that begin and end within the hand. In other words, both of their attachment sites are within the hand. Okay, this is in contrast to extrinsic muscles that we saw before. And these were muscles that began outside of the hand and then went to insert into the hand. So they had one attachment site outside on the forearm or on the humerus, and then from there they went to attach onto the hand. So we saw those muscles in the previous video on the anterior forearm. Okay, this time we're going to be talking about muscles of the anterior hand, intrinsic muscles of the hand. Okay, so first and foremost, we're going to start off talking about the carpal bones that we have situated over here. Okay, the carpal bones. So in total, there's going to be a total of 1, 2, 3, 4, 5, 6, 7, 8 carpal bones. Okay, and there are many different mnemonic devices for memorizing them. I'm just going to go through how I like to think about them. So first of all, the radius right here, okay, the radius right here is going to be making most of its articulation with this carpal bone right here, okay? And this carpal bone is a carpal bone that is typically fractured whenever somebody falls on an outstretched hand, okay? And this is the scaphoid bone. This is the scaphoid bone, okay? That's the scaphoid bone right there. Next, so that's the scaphoid bone right here. Sitting right next to the scaphoid bone is a bone that has a kind of a crescent shape to it. So because of that, the old anatomists thought of Luna, the moon. So they named this bone lunate. Okay, that's the lunate bone right there. All right, that's the lunate bone right there. Next, if we keep moving around this way in this clockwise direction, we have this bone right here, which has another bone that sits right on top of it, okay? This is a sesamoid bone that sits on top of it. Well, I shouldn't say sesamoid bone, no. But it's a bone that sits on top of another bone. So this bone right here that forms the base, okay, for the other bone to rest upon, that bone right there is known as the triquetrum. Triquetrum, okay? The one that's sitting on top of it is known as the pisiform. Pisiform. Okay. The pisiform is going to serve as an attachment site for the flexor carpi ulnaris tendon. Okay. Then we have over here this bone that's articulating with digits with the metacarpals of 4 and 5. This is your hamate bone. Hamate. Okay. That's your hamate. Then we have over here this one that's articulating with the third metacarpal, and it's the one that's smack in the middle, and it is the longest, maybe the largest one, but it's definitely the longest one from this view. This is forming the center capital, so it's called the capitate. Capitate. Okay, that is your capitate bone. Next, we're going to have this one right here that articulates with the second metacarpal, and then we have the last one right here that articulates with the first metacarpal. Now, the name of these two carpal bones are quite similar, and I find that they're easy to confuse with each other. Okay, so I'm going to give you a way of thinking about this so that you don't forget about them. So there's the trapezoid and the trapezium. So which one's which? The trapezium rhymes with the thumb. Trapezium articulates and rhymes with the thumb. So trapezium is this one that articulates with the first metacarpal. That's your trapezium. Trapezium. Okay? The other one, you guys guessed it, you know. The other one is a trapezoid. All right? So this one, I need to type. This one right here is the trapezoid. Okay, and altogether you have all the carpal bones. There are many. My favorite mnemonic device is a slightly inappropriate one. Some lovers try positions that they can't handle. Okay, and so this is basically going in 2 rows. So you have your proximal carpal row, which are these 4 bones right here, and then you have your distal carpal row, which are these 4 bones right here. Okay, and we're going to see in another image how the proximal and the distal carpal rows form the mid carpal joint right there. Okay, so that's how you know the carpal bones. All right, now let's move to the rest of the bones, the digital bones. So over here, we number the digits 1 through 5, starting from the lateral side, the thumb side, and then moving medially. So 1, 2, 3, 4, 5. Each one of these digits is going to be composed by a metacarpal. They all have a metacarpal. And then from there, they're going to have a series of phalanges. Okay. The thumb, or the pollex, as we like to call it in Latin, the pollex contains a set of 2 phalanges. Okay. Whereas the rest of these digits contain sets of 3 phalanges. Okay. So because of that, these fingers right here, 2 through 5, these digits 2 through 5, they're going to have an extra joint that the pollex, digit 1, does not have. Make sense? Because over here we have a total of 1, 2, 3, 4 bones to make 3 joints. And over here we have a total of 3 bones that make 2 joints. Okay? All right. So those are the digital joints. And then we can't forget about the joint that's going to be formed right here between the carpal bone and the metacarpal. Okay? So we have the metacarpals, right, which are these guys. Metacarpals. Then we're going to have the proximal phalanges. Proximal phalanges. Then the next one is going to be the middle phalanges. Middle phalanges. And you guessed it, the last one, distal phalanges. Okay? And as I said, for the first digit, we're only going to have a metacarpal, as all the digits have. We're going to have a proximal phalanx. And we're going to have a distal phalanx. There is no middle phalanx on the first digit. Okay? So now we're going to see how that breaks down into the joints. Okay? So remember what I said before. We have your proximal carpal row, which is made out of your scaphoid, your lunate, triquetrum, and pisiform. And then you have your distal carpal row, which is made up of your trapezium, trapezoid, capitate, and hamate. In between the two, there's going to be what's known as the mid-carpal joint. Mid-carpal joint. And then over here, articulating between the radius and the ulna, we have what's known as the distal radial ulnar joint. Okay? And remember that there's movement happening between the radius and the ulna, particularly whenever you supinate and pronate the forearm. Okay? So the proximal end of the radius and the ulna are fixed in place, with the radius basically spinning in place as this distal part moves over and around the ulna. Okay, and that movement over and around is happening at this distal radial ulnar joint. That's where the sliding is happening. Okay, then there's gonna be the radial carpal joint. Okay, the radial carpal joint, which is articulating between the radius and mostly scaphoid and some of lunate. Okay, that's the radial carpal joint. That's essentially your wrist joint. That's the actual wrist joint, your articulation between your forearm bones and your hand bones. Okay, the mid carpal joint, however, is also part of the wrist joint. Okay, so it's kind of a complex joint with both of these articulations that participate. So whenever you move your hand at the wrist, most of the movement is happening here at the radiocarpal joint, but there is also a small amount of movement happening at the midcarpal joint that adds to that range of motion. Okay, all right. And there is no, and so in terms of ulnar, somebody may ask, why is there a radiocarpal joint, but there is no ulnar carpal joint? Okay, you see that there's a gap right here. All right, there is no actual articulation between the ulna and the carpus, except whenever you're bearing weight on your hand. Okay, like if let's say you're doing a handstand or something like that. Okay, or a push-up. There would be an instance where the ulna is actually making contact with the carpus. Besides that, it's not making articulation with the carpus, and if anything, even in the weight bearing position, it's not making direct contact because there is a piece of fibrocartilage that sits here called the triangular fibrocartilaginous complex that sits in that space right there. So so it's not really, it doesn't really contribute too much to wrist movement. This interface between ulna and carpus. Okay, so really it's radiocarpal joint and midcarpal joint. That's your wrist joint. All right. Then we're gonna have the other joints. So I mentioned the carpal metacarpal joints. Okay, which are these down here. So let's name them carpal. I'm gonna do the dash. Carpal metacarpal joint. Okay, and you're going to have carpal metacarpal joints of joints 2 through 5. And you're also going to have the first carpal metacarpal joint. And now the reason why, carpal metacarpal, the reason why I am making a distinction between the first carpal joint and carpal joints 2 through 5 is because in terms of their mobility, they're quite different. So carpal metacarpal joints 2 through 5 are, for the most part, immobile. Or I should say 2 through 4 are mostly immobile. 5 has some mobility to it, okay? But it's kind of like these 4 over here are kind of like the more rigid ones, 5 being the one that has the most freedom of movement between these 4, okay? But out of the whole hand, the first carpal metacarpal joint is the most mobile. It's very mobile, in fact. Okay, so the carpal metacarpal joint that belongs to the thumb, that belongs to the pollex, is very mobile. I mean, you could test it on yourself right now. Look at how that thumb moves, baby. All right, it's got a lot of range of motion to it at that carpal metacarpal joint. Okay, so in the first carpal metacarpal joint is a saddle joint, which means it moves pretty much in two degrees of freedom, aka moves through 2 planes. So it moves through the sagittal plane to produce flexion and extension of the pollex. Moves through the sagittal plane to produce abduction and adduction of the pollex, and then moves through the coronal plane to produce flexion and extension of the pollex. Okay. So first carpal metacarpal joint, very mobile. The rest of these carpal metacarpal joints are not. The fifth has a little bit of mobility to it. And the fact that the first and the fifth are the most mobile, the ones that are all the way at the end, is what allows us to basically form a spherical shape of our palm and hold something like a ball or a bar or a branch in our hand. That makes sense. It kind of allows us to make that kind of like cup-like structure with our hand. Okay, so that's the carpal metacarpal joints. Next, we have the metacarpal phalangeal joints. Okay, the metacarpal phalangeal joints. Okay, and these are the joints that are involved whenever you punch somebody in the face. Okay, so these are your knuckles, essentially, that most people talk about. So your metacarpal phalangeal joints. You also have a first metacarpal phalangeal joint that belongs to the pollex. The first metacarpal phalangeal joint is not that different from the rest of them in terms of its range of motion. Metacarpal phalangeal joint. Okay, so that's your first metacarpal phalangeal joint. It doesn't differ from the other ones in terms of its mobility. So the metacarpal phalangeal joints are condyloid joints. So that means they're able to do flexion, extension, abduction, adduction, and a nice little motion called circumduction, which is basically like moving. Like if you take your index finger right now, you move it in circles with while keeping your hand still, right? That right there is circumduction, right? But you can flex, you can extend, you could also move it side to side in abduction and adduction. So those are the metacarpal phalangeal joints, and we're going to see that there's going to be a set of muscles inside the hand that lie in between these metacarpals that they basically exert their force across the metacarpal phalangeal joint, and they will allow these digits to wag side to side, as in when you're saying no, for example, right? They'll wag them side to side to cause that abduction and adduction movement of those digits, okay? So that's happening at the metacarpal phalangeal joint. Next, we have the phalangeal joints, okay? And the thumb is going to have one and only one phalangeal joint because it only has two phalanges, proximal and distal phalanx. So it's going to make the interphalangeal joint, okay? The interphalangeal joint. Whereas over here with the rest of the digits 2 through 5, right, we have two sets of interphalangeal joints. So we're going to distinguish between them by using the words proximal and distal. So the one that is closer to the rest of the body will be our proximal interphalangeal joint. Okay, that all got stacked up there. And I'm going to write down here the other one, distal interphalangeal joint. Okay, not point, joint. All right, so the distal interphalangeal joint, which would be these guys right there. Let me highlight it for you so you make sure you're looking at the same thing that I'm looking at, right? So right there, those are the distal interphalangeal joints, and these are your proximal interphalangeal joints. The interphalangeal joints have 1 degree of freedom. They only move through one plane, which is flexion and extension. They move through the sagittal plane to produce flexion and extension, and that's all they do. They're hinge joints, okay? So they're not going to move side to side in abduction and adduction. That side to side abduction, adduction movement of the digits is produced at the metacarpal phalangeal joints, okay? That's produced at the metacarpal phalangeal joints. All right, first muscle we're going to talk about, dorsal interossei. The dorsal interossei. Dorsal means we're on the posterior aspect of the hand, okay? We're on the posterior aspect of the hand. But so these muscles, for example, I can see them clearly. If I take the skin off the dorsal aspect of the hand, I can see them clearly, okay? They're going to be the first most superficial muscle from the posterior aspect. But remember, we're dealing right now with an anterior view of the hand, okay? Pretend this is an anterior view. All right, this is lateral, this is medial over here. So from the anterior view, the dorsal interossei are the deepest muscles in the hand, okay? Remember, I always start these things off with the deepest muscles first, and then we layer the muscles on top of them, okay? So the dorsal interossei is the first layer of musculature of the intrinsic muscles that we're going to find. And where's it attaching? Interossei. If you break that word down, that word means between, right, bones, between bones, okay? Which bones is it going to be lying in between? The metacarpals, okay? So it's going to be attaching to the sides of adjacent metacarpals. That just means metacarpals next to each other, right? So it's going to be attaching to this metacarpal, the first one, and the second one. Then there's going to be another dorsal interossei belly that's going to be between the second one and the third one, and then another one between the third one and the fourth one. And then where do they go from there? They run up to insert onto the extensor expansions of digits 2 through 4. What does that look like? It looks like this, okay? The extensor expansions, remember, this is an anterior view. So from here, these tendons are going to go out of our view behind this digit, okay, to the posterior side to insert onto the extensor expansions. Remember, this is a tendinous complex that is formed on the dorsal aspect of each one of the digits, and that is how force is exerted throughout all three phalanges and the metacarpal phalangeal joint on the extensor side. So what does that tell us? That tells us that this dorsal interossei, these dorsal interossei muscle, what can they do? They can extend these digits. Whoa, okay? They can extend these digits, but specifically where? Okay, so if you look at how these dorsal interossei are constructed, okay, and how they cross over that joint, if we were to look at this metacarpal phalangeal joint, for example, if we were to look at it from the lateral side, let's say we were looking at it from this side, okay, our eyes are over here looking at it from this way. If we were looking at it from that view, what we would see is this. We would see, let's say this circle is my metacarpal phalangeal joint, and this dot right here is the center of that joint, okay? And this is the rest of the finger over here. Let's say this is the proximal phalanx, okay? So this is the metacarpal phalangeal joint right here, and let's say that's my metacarpal. And let's say this is my extensor side, and this is my flexor side, okay? So that tendon, right, is lying right at the level of this metacarpal because it's attaching from one metacarpal to the other. So it's here, okay? It's right here. And then from there, it's going to run anterior to the metacarpal phalangeal joint on the flexor side. You see that? But then it's going to turn up this way to attach to the extensor expansions. So what that does is that basically it makes it so that this muscle, the way it runs, okay, it's able to cause extension at these interphalangeal joints up here and here, okay, because it's attaching to the extensor expansion. But as it crosses over the metacarpal phalangeal joint, it's crossing anterior to its axis of rotation, which is this dot right here, okay? It's crossing anterior to that, which means that over the metacarpal phalangeal joint, it's able to do flexion, okay? It's able to do flexion. And we're going to see the same pattern that's going to happen with the dorsal interossei, the palmar interossei, and the lumbricals. These three muscles do that, okay? So that's the dorsal interosseous muscle, or muscles, I should say, okay? Now, let's get all that out of the way. So, but that's not even, so the flexion and extension thing, flexion at the metacarpal phalangeal joints and extension at the interphalangeal joints, that is one function. But the main function and the thing that the interossei are always lauded for is their ability to produce either abduction or adduction. Okay, either abduction or adduction. And there's a very simple mnemonic for remembering which one does which. But before I tell you the mnemonic, I want you to understand why each one does which. So let's look. So over here, I drew a line that's going through the third digit, okay? The third digit is essentially the center line of the hand, okay? So this is the center line of the hand, also known as the axial line of the hand, okay? So whenever we produce abduction or adduction of the digits, we're producing abduction and adduction as a convention, and also looking the way anatomy designed it. We're talking about abduction and adduction relative to this axial line. Okay, relative to this axial line. So in the rest of the body, whenever, like, say, we abduct the arm, our whole arm is moving away from our body, right? Or we adduct the leg, our whole leg is moving towards our body. With the hand, when it comes to the digits, we're talking about away or towards the third digit. That's what we're talking about, okay? Or more specifically, away or towards an imaginary line that runs through the third digit. Okay, so looking at the way these dorsal interossei are constructed, notice how muscle belly's here, and then the tendon goes up and around that way. This one goes up and around this way. But over here on this side of the axial line, it goes up and around and towards the axial line like this. up and around towards the axial line like that. So what does that mean? That means that the force vector produced by these muscle bellies is going to be a muscle vector that is away from the axial line, right? So for example, this dorsal interosseous, the fourth dorsal interosseous that is attaching to this fourth digit over here, is going to pull that fourth digit that way, okay? This one over here, the third one, is going to pull the third digit that way. The second one over here is going to pull the third digit in the opposite direction. And then the first dorsal interosseous is going to pull the second digit in that direction. So all of these force vectors are going away from the axial line. So they're all causing abduction, right? A, B as in boy, duction, okay? Abduction of the digits, okay? And then you may ask yourself, well, the third digit is getting abducted this way and it's getting abducted that way. Are they both called abduction? Yes, they are both called abduction. We make the distinction by calling this one, we call this one that's moving out laterally, we call this one lateral abduction, and this one that's moving medial, we call it medial abduction of that third digit. All right? Beautiful. Next, we move on to the Palmar Interossei. Okay, the Palmar Interossei. So same thing, attaching to sides of adjacent metacarpals, right? They're Palmar Interossei, so they're lying, if we're looking at this hand from the anterior view, they're lying superficial to the dorsal interossei. Okay, so you cannot see the Palmar Interossei if you're looking at the dorsum of the hand, okay, because they're hiding deep to the dorsal interossei. So Palmar Interossei are going to be attaching to the sides of these metacarpals. Okay, there's not going to be 4 of them, there's going to be 3. They're attaching in here, in here, in here, and then they run up to insert onto the extensor expansions of 2, 4, and 5. None of them are attaching to 3. Okay, what does that look like? That looks like this. Okay, so following the same train of thought, right? We can see how this interossei is running to attach here. This interossei is running to attach like that. This interossei is running to attach like that. So now the way that these are pulled, this first Palmar Interossei is going to grab that second digit and pull it in this way. This second Palmar Interossei is going to grab that fourth digit and pull it in that way. That third Palmar Interossei is going to grab the fifth digit and pull it out that way, okay? So notice that these are now pulling them towards the midline. They're pulling them towards the axial line. So therefore, the Palmar Interossei are capable of doing a deduction, D as in David, adduction, all right? And the mnemonic device that people typically use is, it's very simple, dab and pad. You can't see it here. It's probably super, super small. Let me make it a little bit bigger for you. Okay, but pad and dab, or dab the pad, or pad the dab, however you want to think about it, all right? Dorsal interossei AB duct and Palmar interossei AD duct. Good. All right. Next, we talk about the lumbricals. The lumbricals are interesting because they have an attachment site to tendons as opposed to bone. Okay, so they actually attach to the tendons of the flexor digitorum profundus. Okay, and then from their attachment site to the flexor digitorum profundus, they will then run up to insert onto the extensor expansions of 2 through 5. Okay, 2 through 5. So they do the same thing those interossei do. They flex at the metacarpal phalangeal joints, but they extend at the distal and proximal interphalangeal joints of digits 2 through 5. Okay. Do they do any kind of abduction and adduction? No, they do not. No, they do not. The lumbricals are responsible just for doing that flexion of the metacarpal phalangeal, and they also extend the IP joints. They also, I remember reading somewhere in some kinesiology textbook that they assist the flexor digitorum profundus in its contraction. So, kind of like helping the flexor digitorum profundus do its job. Okay, because it has a very long travel to go all the way to the distal phalanx. So as it shortens and pulls that distal interphalangeal joint into flexion, it can get some laxity on it that the lumbricals basically offset that laxity that would be created and add some tension to those tendons to assist in the flexion that they're producing. Okay, that's what the lumbricals do, and this is how the lumbricals would look. Notice that these two over here are they have a unipennate structure, and these two over here have a bipennate structure, and their innervation is also different. All right, so these two over here will be innervated by the median nerve, and these two over here will be innervated by the ulnar nerve. Okay, those are the lumbricals. Next, we have the opponens digiti. So now we're going to go into the hypothenar eminence. Okay, the hypothenar eminence is the mass of muscle that you have on the medial aspect of your palm, or on the medial border of your palm, that is associated with the fifth digit. Okay, and that is in opposition, to the thenar eminence, which is on the thumb side. Okay, that's the mass of muscle that you have on your thumb. Okay, so we're going to talk about those two guys now. So first, we're going to start with the hypothenar eminence, and the first muscle, the deepest muscle of the hypothenar eminence, is the opponens digiti. The opponens digiti, all right? And these muscles are going to have attachment sites to the flexor retinaculum, which serves as a part of the roof of the carpal tunnel, okay? So the flexor retinaculum, the hook of the hamate is going to be the proximal attachment, and then distally, it's going to attach to the medial side of the fifth metacarpal, all right? The medial side of the fifth metacarpal. And so what is that? That's going to look like? That's going to look like this, right? And why am I specifying the medial side? Because of the movement that this produces. Opponens digiti means that it produces opposition. And what does opposition of the fifth digit look like? Opposition of the fifth digit is essentially whenever you bring the tip of your pinky to touch the tip of your thumb, okay? And you make that circle between your pinky and your thumb. That right there is opposition, okay? That's what you just did. And to do that, you need an ever slight amount of rotation. This metacarpal needs to be slightly rotated inwardly, or slightly rotated, how should I say, laterally, okay? It needs to be slightly rotated to face towards the thumb so that it can assist with that opposition. That's why it's attaching out on the medial side of the metacarpal and pulls it also into flexion. So opposition is a combination of flexion, abduction, and rotation, okay? And that's what's happening there. I hope I'm not confusing people too much. Getting too wordy over here. All right, let me keep it simple. Flexor digiti minimi. Flexor digiti minimi is also attaching to the flexor retinaculum and the hook of hamate. And then from there, it goes to attach to the base of the fifth proximal phalanx. Okay, so what does that tell us? That it does. It basically exerts its force across this fifth metacarpal phalangeal joint, and specifically, it's going to flex. So it's going to flex the fifth metacarpal phalangeal joint, okay? And that's going to look like that. That's what that's going to look like, okay? Next one we have is going to be our abductor digiti minimi. The abductor digiti minimi. So we ran out of real estate over here in the flexor retinaculum and the hamate, and it makes sense anyway because this abductor is going to be more on the outside, so it can abduct, right? So it can pull, so that it can pull that fifth digit out this way. Okay, that's what that's there for. So it's going to go ahead and attach on the outer side, right? It's attaching to the pisiform bone and then attaches to the medial side of the base of the fifth proximal phalanx. And remember what I said, the metacarpal phalangeal joint can do flexion and extension, but it can also do abduction and adduction. So it's going to pull this into abduction. I'm sorry, adduction. I'm sorry. No, I was correct in the beginning. Abduction, okay? My bad. I just woke up. I haven't drank my coffee yet because it's too early. But after this video, I'm definitely drinking my coffee because I'm kind of All right. So this is your abductor digiti minimi. Okay. And that's what that guy's going to do. Medial base of the fifth proximal phalanx is going to abduct at the fifth metacarpal phalangeal joint. Beautiful. All right. Next one. Now we're going to start moving into the thenar eminence. Okay. But before that, before we talk about the thenar eminence, we have to talk about some other pollicis muscles that are not specifically part of the thenar eminence. Okay, these are deep muscles that move the thumb. deep muscles that move the thumb. The first one we're going to talk about is the adductor pollicis, adductor pollicis. So it's going to grab this thumb and move it towards that axial line inward, okay? That's what that muscle is going to do. And where it's going to attach? It's going to have a lot of attachments over here to the hand. I don't think anybody's really going to ask you about this. Shaft of the third metacarpal, base of the second and third metacarpal, and the capitate. So basically, second, third metacarpal, capitate. That's what it's attaching to, okay? From there, it's going to go to insert itself onto the medial side of the base of the first proximal phalanx, okay? So it's going to attach right there. What is that going to look like? That's going to look like this, okay? It's going to look like that. So it's going to be able to pull, that thumb in that direction, okay? It's called adduction of the thumb. That's the adductor pollicis. Next, we have now we're talking about the thenar eminence muscles, okay? And the first one is going to be the opponent's pollicis. Just like there was opponent's digiti minimi, we have opponents on the other side that does the same thing. It does opposition, okay? So it's going to attach to the scaphoid trapezium and the flexor retinaculum. From there, it's going to insert onto the lateral side of the shaft of the first metacarpal. So that's going to look like this. And then it's going to pull that thumb over and around, okay, so that the tip of your thumb can touch the tip of your pinky, all right, and that's opposition. Next, we have the flexor pollicis brevis, also attaching to scaphoid trapezium and flexor retinaculum, and then from there is going to run up to do similar to exactly what we saw the flexor digiti minimi do on the other side. It's going to attach to the base of the first proximal phalanx, okay, and that is what's going to give it the ability to now produce flexion at that first metacarpal phalangeal joint, okay, and that's the flexor pollicis brevis. Likewise, next one, the last one and the best one, is going to be the abductor pollicis brevis. And just like we saw over here, the abductor being on the outside, we're going to have the abductor on the outside again. Okay, so the abductor pollicis brevis is going to attach to scaphoid trapezium and flexor retinaculum. Notice that pretty much all of these thenar muscles are attaching to the same place on the carpus. And then from there, the abductor pollicis brevis is going to attach to the lateral aspect of the base of that first proximal phalanx to essentially assist in abduction at this first the first metacarpal phalangeal joint. Okay, what else should I say about that? Metacarpal phalangeal joint. First metacarpal phalangeal joint is going to do some abduction. It's really, I should say, it's mostly exerting its abduction across the carpal metacarpal joint. The carpal metacarpal joint, remember what I said, that first carpal metacarpal joint is highly mobile. So it's going to produce abduction over there, and it's essentially going to pull this pollex into the screen. Okay, it's going to pull this pollex into the screen. And so when you look at this on a cadaveric specimen, for example, or maybe if it's even like one of those electronic dissection tables, what you'll notice is that the abductor pollicis brevis, right, is basically facing you. All right, it's facing us right now because abduction is a movement through the sagittal plane. So abduction is going to look like this thumb moving towards you. Okay, and if you want a separate video, I think I'm going to make another video on just thumb movements because I get a lot of questions on that. Okay, so abductor pollicis and then flexor pollicis more on the inside because flexion is a movement that occurs on the coronal plane. It's just going to move this thumb right across that way. That's what flexion would look like. So that's why the flexor pollicis brevis is more on the inside of the thumb over here. Okay, so that is it for the hand. Thank you very much for listening. Gross anatomy is one of the most difficult subjects in the world. Luckily, it doesn't have to be. Anatomy is one of those subjects that needs constant verbal and visual repetition in order to get good at. What better way to reinforce this information than with the scientifically validated method of drawing? Neuroscience has shown us that we retain information better when we physically draw it out. That is why the Gross Anatomy Study Strategy Workbook is designed to walk you through all the layers of the musculoskeletal system, allowing you to draw the muscles into place. This is excellent for reinforcing muscle attachments, bony landmarks, muscle names, and actions. This will save you tons of time from mind-numbing tactics such as repetitive flashcards or passively listening to boring lectures. With this strategy, you can actually begin to enjoy studying again and have a much better way to retrieve the information. Order a copy of the Gross Anatomy Study Strategy today at the link below so you can spend less time being stressed and more time being blessed.